Hello, everyone. All right, I think I'm all set up. So we are going to do a video on linear applications. So usually you're going to get a problem where there are two different types of quantities, and it's your job to figure out how those quantities are interrelated. You want to make a system, and then you want to solve that system. So I'm going to read this first one. It says, actually the only one, it says, Carrie asked a bank teller to cash a $390 check using $20 and $50 bills. If the teller gave her a total of 15 bills, how many of each type of bill did she receive? All right, so the first thing I like to do is figure out what type of quantities have been given to me. And that usually comes in the form of our variables. So as I read this, I see two different types of quantities. I see bills and I see money. So I'm going to say that that's really where you need to start off. And we're going to need to have a quantity equation. And then we're going to have our money equation. So now that we know that we're going to have a money equation and a quantity equation, now we have to make those variables. And I'm going to look in the information here, and it says that $390 was the total. So I know over here that 390 is going to be the money equation, and then the quantity equation is going to have 15 as our total, because there's 15 bills. Now, we need to figure out what made those bills, right? What made up the bills, and then what made up the money. So I'm going to say, let's see, 20 starts with a T, and 50 starts with an F. So I'm going to say that T is the number of 20s, and we'll say F is the number of 50s. So now we're going to have to figure out how do we make the quantity equation and the money equation using T and F. So I think the easier one is the quantity equation, because we know that between the 20s and the 50s, we'll make 15. So the quantity equation is the simpler of our two. We have 20s plus 50s is going to give us 15 bills. Okay, we can say bills there. So my suggestion is try and make the other equation, pause the video right now, and see if you can make what the equation should be for the money. So pause. All right, welcome back. Hopefully by now you figured out that the money is going to have not only just the variable, but it's going to have a coefficient, because for every $20 bill, there's $20. So I'm going to have 20T plus 50F. So that way, imagine if we had one bill of each, we would have 120 and then 150. That would only give us 70, which is not equal to 390. So we know that 1 and 1 isn't our solution, especially because here 1 plus 1 would be 2. 2 isn't the same as 15. Okay, so what we're going to have to do is use this information to solve our system. So first things first, let's put them on top of each other. And I noticed that this has a 0, this has a 0, and this has a 0. So I'm actually going to divide everything by 10 to make this a little bit simpler. And you are allowed to do that, right? Because just like with elimination, you can multiply an equation and it doesn't change its actual value. It just magnifies the equation. So I'm going to write 2t plus 5f equals 39. And you might be thinking, why is he doing that? Just to confuse me? No. I'm doing this because I want you to know that whenever possible, you should use smaller coefficients, right? I think that just makes sense. Now, I'm looking at this, and I see 2t and 1t, 1f, 5f. So I'm thinking this is a prime candidate for some elimination. I'm going to take this equation and I'm going to multiply it by -2. That will then give me -2t minus 2f equals -30. I could have chosen -5, but then 5 times 15 is a bigger number, so I just was trying to avoid using big numbers. And I'll take the 2t plus 5f equals 39. And watch how nice this comes out. We get 0t, so that's bye-bye. -2 plus 5 is 3f equals a nice simple 9. See how that worked out lovely for us? So we now know that we have f equals 3, and that was 3 50s. So we're done. Just kidding. We're not done. We now need to figure out how many 20s there were. But that's a relatively simple task because we have a pretty simple equation. The quantity equation would be t plus f equals 15. And I'm going to take that 3 and we're going to substitute it in. Subtract the 3. And I get t equals 12. So at this point, I would say a lot of students kind of decide to wipe their hands and say, I'm done. Algebraically, you're done, right? Algebraically, you're done. You found your variables, you found your equation, you solved the equation, right? You solved it, but I like to say there's a fourth step, and that is context. We need to let the reader know, right? Look back at this question. How many of each type of bill did she receive? Saying t equals 12 and f equals 3, that doesn't tell the reader how many bills she received of each, right? So you have to TTQA, turn that question around and say, what is the actual answer to this question? Not what are the variables that were the mechanism that helped me find this, right? So some little ins and outs, but anyways, I'm going to look back at how I defined my variables. T was 12, so I'm going to say 12, 20, 20s bills. And we had 3 50s bills. Now, step 5, I would say is optional, but I do like to do a little check here and make sure that the other equation, the 20 times the t, so we had 12 of those, plus 50, we have 3 of those. Make sure that equals 390. So 2 times 12 would be 24. So 240 plus 150 equals 390. And 390 does equal 390. So there we go. That was our check. And this was our answer. Okay? So hopefully that gave you a good idea of applications and kind of like a nice flow for how to find that. Okay? So hopefully you enjoyed that one, and I'll see you soon.